Okay, so good evening, guys. Welcome back. We will continue with our Kubernetes session. So today is Kubernetes day 8, and the date is 19th of your March, and the timing is evening. It is 8, right? 8:31 p.m. IST. Okay, so thank you guys for joining the session. So, like today is a day 8. So, in the day 7 session, if you recall the day 7 session, we try to understand about what exactly API groups are, right? And what do you mean by versioning, right? That's and all we had discussed about that. And also we discussed about some of the examples, right? Where we are trying to understand like how we can able to write or how we can able to write a manifest file where we are trying to create a resource and the resource is pod actually, right? With various examples, we were trying to understand how we are able to write a manifest file, right? So let us try to continue the same today, right? And in the day 8 also, we'll see few examples, and also we will also try to discuss few of the other things, like we have some topics like there is something like resource management or resource limits we say. So that we will discuss it, right? And also we will try to see what are labels. We will try to even cover few of the stuff in today's session. Okay, so guys, let us try to continue with our discussion with a few of many more other examples. Like in the last session, I think the last was example 4, right? Where we try to pass some environment variables. Like we took an example in the Docker when you try to create a MySQL container, right? Basically, we try to pass some environment variable. The same thing I want to do, the same thing in our like in the Kubernetes, how we can able to do a manifest file. So I think I didn't wrote the YAML thing. Let me copy paste from over here. So pod 4, I think this is what the YAML file what we had. Okay, fine, right? Okay, let us try to go with the today that the last was example 5, right? Okay, example 4, sorry. Let us try to go with example 5 today. Okay. So let us try to understand how we can pass. Say, for example, guys, for example, in Kubernetes, in a Kubernetes, we know something like we create a pod, right? So pod is the smallest deployable unit in your Kubernetes. We call it a pod. Whenever we want to run any application or any kind of a microservices, we run inside a pod, and inside a pod, a container is present. It means that a container will be running actually, right? So we only know that much, right? We only know some high level of what exactly pod is all about. But in our upcoming session, probably tomorrow, in tomorrow's session, what we'll do, we will try to deep dive into more into what exactly pod is all about, what are the pod contains actually, and few other stuffs we are going to learn. Like for example, we'll be also be understanding what are the different states of pods actually. We know that we are having a different states of Docker, right? Same thing when we will try to learn about the pod, we'll also try to understand about what are the different states of pod. Okay. Now, coming back to this example, guys. So in example 5, what we do that we know that in Docker, when it comes to Docker, we know that actually Docker containers. I think we might even need or we might need to pass a CMD, or we call it an entry point, right? So basically, we know that we always try to pass a CMD or entry point, right? Without CMD or entry point, we know that actually we will not be able to run that container. Same thing in case of I want to pass a CMD or entry point, how I can able to pass it in Kubernetes pod actually. In the Kubernetes pod, I want to pass something like a CMD or entry point like that. I think we had already covered about this, right? If I'm not wrong. In the last session only I have covered it, but anyhow, that's fine. Let us recap again. I think we'll be able to we'll be able to understand a better way. Like so, CMD or entry point, we know that we always try to pass whenever we're writing a Docker file, right? When we write a Docker file, we know at the end of the file, we write a CMD or entry point, or sometimes we use a combination of both CMD and entry point. And also, we had discussed many times what is the difference between CMD and entry point. I'm not going to discuss here, but we know the differences, right? So similarly, what happened? I want to pass either CMD or entry point when it comes to the Kubernetes pod. How I'm going to do that actually, right? So basically, guys, we know that actually that whenever, suppose for example, in case of Docker, I want to create a container with CMD or without CMD. How we do that? I'll just say Docker container run hyphen D, and I'll just say hyphen name, give the container name. I'll give something like a test one. Okay. And I'll just say I'll use Alpine. So when I run this command, we know that this container will get created with this image Alpine, but it will immediately get exited out because that as when we run this container, right, Alpine is not an application image; it's a OS image. So when you try to run as a container, what happened, right? That OS, I mean, that container will get created where the Alpine image is loaded, but there is no CMD with which this Alpine can run it actually. That's what happened, right? You know that as soon as you run this command, it's going to create a container, but it will be in exited state. Now you say that I want to run this container, right? So what you do, you try to run like this way. Docker container run hyphen D hyphen F name. Say for example, I'll give test 2 and I'll just say Alpine. Then I need to pass some parameter, like I'll just say sleep of 1D. So you hear what happened at this sleep of 1D. What you're trying to do that you are trying to pass it as an CMD to this Alpine image actually. It acts like a CMD, command line kind of a stuff, where the CMD will try to, it will be passed as CMD as an argument to this Alpine image. So inside this Alpine image, a CMD will be there. There will be default CMD. So that this sleep 1D is going to override the default CMD of the Alpine. And then what happened, that you are just passing saying that you want to make your container to sleep for 1 day. So it means that the container will keep running, but it will be in a sleep. It means that it will not accept, it will not receive any kind of a request, but the container will keep running. So in this way, we are able to keep the container alive. Right. So here in this case, guys, in case of a Docker, I'm just passing here directly these arguments like sleep 1D. But the same thing I want to pass inside your pod, or when you're constructing a manifest file, I want to pass it. How to do that actually? That is what we are going to understand it. Okay. So let us do one thing. Let us try to go to our server where you have two servers, one is the master and the worker node. Let me log into the master node first. Copy the public of the master node. Go over here. Go to the downloads folder. I'll just say ssh-i, specify the key name, and I'll just say Ubuntu at the rate, give the public IP of the master node. So you're able to log in it. So I'll do one thing. I'll try to log in even the worker node also. So that because I know that the Docker is installed over everywhere. So I want to run the Docker command. Okay, ss-i Ubuntu at the rate, give the IP address of your worker node, that is node 1. Guys, some of you have asked me that Rajesh, do I have to really create this, create this servers like, or create this cluster and practice it? Yeah, it's good that you practice it. But what happened, guys, 90% of the things you can able to do, achieve everything through the killer coda. So you remember that I have a killer coda, right? This is what the URL is. So if you try to go to the killercode.com, register yourself, guys, you will be able to launch the Kubernetes with one control node and with one control node and with one worker node. So that is sufficient for you to practice all your examples, whatever you're learning. But yeah, see, you could see that, guys, I'm able to have one, have a see, you could see that I am able to have a cluster over here, right? So if I execute kubectl, get nodes, you see that I have a control plane and I have one worker node. This much is sufficient for us to practice everything, guys. So I don't see that we need a cluster as of now. So you could see that in next few sessions, right? You don't really need it actually. All the things what you need is a clear coda. It will be available for 60 minutes. Please try to go through all the videos first, make a note of everything, and then then launch the killer code and practice it actually, right? So in order to really go and create it, when you need the cluster, when you need an actual cluster like this, suppose for example I'll be discussing something about the auto pod scaler, or else I'll be discussing something about the deployment, I'll be discussing something about the load balancer, I'll be discussing on something like a ingress controller, right, as well as a gateway API, or else I'll be discussing something about RBSE security stuff, or I'll be discussing about the rolling upgrade or upgrade of your to a green blue deployment. So such topics you want to see it, right? It is better that you have your cluster. Apart from that, you want to learn the conceptually, you want to learn about many of the things about the Kubernetes and all this concept, right? You can able to easily do everything in this playground itself actually. killer coda. So what I would suggest at this point of time, don't go with creating the cluster, because whatever I'm doing till now, you'll be able to achieve everything here in the killer coda itself or under this playground, killer coda playground. So you need not to really go and do it. For me, why I'm doing guys, because I'm taking a class, I have to show in the live how exactly you are able to do. That's what I'm having this cluster. Otherwise, the same thing I would have shown even here also. But why I'm showing, because that you will be able to understand like what I'm doing it everything over here by logging to the server, executing certain examples, and like I'm showing you some configurations, everything. So I might need an actual cluster actually. For you guys, for certain days you don't need it. You can just depend on that. Later, after some point of time, you will know, okay, for me to understand many other things, actually, I need a proper cluster. At that time, you can go and create this cluster. Am I clear, sir? So I thought to tell you about this at the very beginning, but I said, okay, later, once we go with little bit flow, right? At that time, I will be able to inform you about this, that you don't need a cluster as of now. You can just, if you have it also, guys, you can just go and delete the cluster, okay, so that you can save your timing and the money or the credit points, what you have with the cloud. And then like you can go switch to the playground, and there you can practice everything. So at a certain point of time, when I come to something like controllers, right? At that time, I might tell that, okay, guys, go and have your own cluster. Even controllers also, I don't see anything that you need you need to create a cluster. But for certain topics, like I want to show you taint, untaint, cordon, uncordon, like that way, what happened that you need to have minimum more than one node, one worker node, like node one, node two is required. At that time, what happened, guys, you might need a complete no cluster setup. For understanding, for some few topics only, you need a cluster actually. Otherwise, you can practice most of the time, 90% of things you can practice here only. Only 10% of the concepts only you need a actual cluster setup actually. Am I clear, sir? So with this, I would recommend you to always follow the killer coda and then try to practice here yourself. No need to have a setup over here, right? I will tell you when it comes, I will tell you, okay, guys, now you perform all this activity in your own cluster. I will tell you at that time, then only you practice, you have your cluster. Otherwise, you practice in killer code only. Okay, coming back here, let me log into my node one. So node one, I have logged in, guys, and in the master also, I have logged in. Okay, let me do one thing. Because we know that Docker is installed everywhere. What I will do that, just to reproduce this one, what I will do, guys, I will try to run this container. So what I'll do, Docker container run -fn name test one, and I'll just say Alpine. So you could see that it has created a container, but it has exited out. How do you verify it? If you try to do a Docker container ls-a, you could see that actually that your Alpine container hasn't exited, because you're not passing any argument over here. You're not passing a CMD. It is, so what it will do, ultimately it will get created, it run on a container, and then immediately get exited out. Right? Now you say that, okay, I want to run it as a container without, I mean, it should not get exited out, it should run, right? Then what you will do that, you will just try to pass something like sleep of 1D. Okay, okay, I think I have to give the other name, sorry. We give something like test 2 here. Okay, it's already been used actually, okay. Okay, what happened? It's taking time. It should not happen like this. There's so many contents are running actually. Exited. 1 second, guys. kubectl get nodes. Let's check they are in ready state. Okay. Kubectl get nodes or get parts -n cube system. Yeah, everything Weave network, everything is running fine. Okay. Okay. Docker container rm-f gave the test one, and also test two also is created. Test one, test two both were created actually. Right. So that's what, like, let me check what is the availability. Oh, free is 7. Okay. Free is only 117 actually. Used this much. Okay. Available 442. Okay, fine. I think because of this node, right? Like, so let me run this one more time. So it is creating, right? It is creating a container. So same thing as what I'm doing that here. I'm trying to do that. Basically, I'm trying to have the same stuff, what I'll be doing that I'll be writing a manifest file for that, right? So what we'll do that we'll go over here and then like we will try to create a file, something like a pod 5.yaml. Okay. Now, so we know very well that we always start with three hyphen and then like we have something like a API version, which is nothing but the V1, and we have a kind, what is it? It's pod actually, and then like we have a metadata. As of now, as I said that we will be having only one field, that is name actually. And what is it actually? Here you are just saying that arguments arg container, something like that. Okay, or arg pod actually, because you are passing either CMD or entry point. That's what you are trying to understand it. That's what I'm just saying, arg pods. Okay. After that, you are having something like a spec. So here what happened? We know that in the API version, if you go to your Kubernetes API resources or API references, you have to go to the reference document. Right here, you have to go to the one page reference document, guys. And here, if you go to the pod, actually under the under this, you could see that you have something like pod. If you click on it, this is what the four fields we have written already, right? Under the spec, it is of a type pod spec. Actually, that's what I went to tool next line and give two spaces. You click on the pod spec, and here you have something like you can give a name and you can give something like a container actually, or name is not that, just containers. So I'm just giving a containers. And here what happened, container is of a type of container array. So I have to give two spaces and I have to start with a hyphen, right? So here what you do guys, you have to just go to this container array, click on this container array. So it will take you to the page where you can pass some parameter. Like here you could see that I want to pass a name as well as I have to pass the image, right? These are the two parameters you have to pass it. So name is something like I'll just say Al, okay? And image is nothing but an Alpine, right? And what else you want to create? So guys, we know that actually like we have to pass, for example, here, in this case, basically, when you come to this one, this is an Alpine like OS image. What we are doing that we are trying to run or we are trying to pass some two arguments. So this acts like a CMD. It is not entry points to CMD. For that, what we do basically, like if you go up here, can we say something like an args is there, a command is there? Args is something like where argument to the entry point. Argument to the entry point means this is the CMD actually. It is an argument to the entry point what you are passing it. The container image CMD is used if this is not provided. Variables references, something like variable underscore name are expanded using the container environment. So for example, if any kind of a container where there are N1 variables are there, even you can pass that also with help of this args. If the variable cannot be resolved, the references in the input string will be unchanged. Double dollar are reduced to single dollar, which allows for escaping something. They have given all this information. You can go through it, right? Suppose if you are constructing a pod where you want to pass an entry point or you want to pass a kind of an entry point, what you pass in the Docker container, then in that case you have to pass something as a command. So entry point array, this command is something, it will act like an entry point array, right? Not executed within a shell. The container image entry point is used if this is not provided. So basically what I'm saying that wherever if you're using CMD, then you have to use args. Wherever you are using the entry point, you have to pass something like a command. So here you could see that arg and it says that it's a string array. If you want to understand more about this or get examples about all this, you could see that they're given a URL over here. You can just copy this whole URL and just paste it in your browser. You will be seeing that you can see that some examples they are given it. See here, you can pass a, like you could see that you can pass a command line, you can pass an argument like this. This is something like an array type actually. So same thing what I'm doing here over here is that actually that in case of your here, what I'm doing that I want to pass an args. So I'll just say args and give, it's an array actually. So you have to give two spaces and I have to start the hyphen sleep of 1D. So that's all guys. So here guys, you could see that actually see this Alpine image itself is not able to do it because here you could see that this is the node 1 and it is just a T2 micro. Even though I have given, like even though I have given 15 GB as a disk space, but you could see that RAM, right? If you go to the free -m, you could see that RAM memory is not free actually. See, it is very less actually. So what I want to say that actually that even though if you're using node for the node itself, you are trying to take T2.micro, that itself is not sufficient. So in the next class, what I'll do that I will try to increase from T2.micro to T2.medium. I'll increase it so that you will get more RAM memory and more CPU are going to get. That's what I will be doing in the next class. Okay, I will not be doing now actually. But anyhow, for our requirement, yeah, okay, it will run. So if I try to do a Docker container ls here, guys, I think that Alpine is running over here. You could see that it is running, it didn't exit it out, right? It's still running. So let me try to stop that so that we don't need that container now. Okay, test 2. Let it stop. And again, I'll do a Docker container ls. Okay, it's gone. So Docker container ls-a. Yeah, everything is gone, guys. So nothing is there. So what I will do, guys, I will just try to come over here, copy this whole stuff, right? Go to your server where you have master node. I think it is like exited out. So let me relog in. Okay. Now, if I get inside the manifest folder, here you have something like pod files I'm minting over here. I'll just say pod-file.yaml. I'll just paste this, right? And I'll save this file. Now, if we try to do a kubectl apply -f pod-y.yaml. So you could see guys, it has applied it. When I try to do kubectl get pods, you could see that the pod has come into the running state. Am I clear, sir? So in this way, you are able to pass the argument. So how to pass the argument? You have to pass something like args, right? I think we already learned this in the last session, I think, but still anyhow, it is kind of a repetitive only. That's fine for us. Okay. So let me do one thing. Let me go and delete this pod actually. So how do you delete it? You'll just say kubectl delete -f and specify the YAML file that is pod-5.yaml. Okay. So let it delete. Okay. Now guys, now this is the example 5. Okay. Let us try to understand about the example 6 now. Let us see what we're going to cover in the example 6. So in the example 6, okay, let us do one thing. Like for example, we know very well that whenever we want to create a Nginx container, for example, I want to create a Nginx container where I want to give, what is it, 256 MB for the RAM and what is it actually, one virtual CPU. I want to provide one virtual CPU or just say one CPU for the container. So I want to give 256 MB as a RAM memory and one virtual CPU or one CPU I want to provide it. How we are going to do it? So we already learned these things, guys. You remember, like in a Docker, the last few sessions of Docker, I discussed more on this itself, right? Where you can do a complete resource management also, right? And after providing it, you know that actually that how to check it out. We always run a command known as a Docker starts command, right? This is a command we used to run it to do it actually. Right now, whenever we try to create a container without providing any details about the RAM or the CPU, so what usually happens, right? Your Docker will decide like how much memory or the CPU has to be allocated for that particular container, right? For example, here I'll go back here again. I'll go to the node, and what I'll do that I'll just say Docker container run -fn name. I'll just give something name as no limits. So I'm not providing any limits. -d detach mode, and I'll just say Nginx. So you could see that guys, Nginx container is running. When I try to do Docker container ls-a, right, you could see that your container is running. Oh, this has become very slow, right? See, Nginx is running here, right? Nginx running. Suppose I want to check it how much is a RAM memory or how much is a CPU used by your Nginx container. Then what I'll do that I'll execute a command known as a Docker stats that will give us statistical information about the Nginx container. So you could see that actually for the Nginx container, that is for the no limits, you could see that actually guys, out of 126, sorry, out of what is it actually? Out of 957 MB, it is using 14 only, 14 MB of RAM memory, right? This much is a RAM memory. I think I should reduce the font size. or else, okay, let me make shorter. Again, I try to run a Docker starts. Still small. Yeah. Now you could see, guys, your container, right? No limit container. It you could see that out of 957 MB of existing memory, RAM memory, your container is consuming only almost 15 MB it is consuming, right? And the CPU what is consuming is almost zero. It's not consuming any CPU at all, right? This is what the statistics you are getting it actually, right? So it means that there's no bound. You're not bounding any kind of limits for your container running because you are just allowed the Docker to decide what is the RAM and what is the CPU has to be allocated for that. But suppose assume that I have to better manage it. To better manage, what I will do that, guys, I want to give some kind of a limits actually. For that, what I will do that, I'll just run a command, Docker container run. We know that we have to always give -FN CPUs for your CPU. I'll give something like a zero point 0.5 CPU, half of your CPU, and I'll give something like -FN memory is something like 256 MB. I'll just say 256, sorry, what is it actually? 256 M. I think I have to mention capital M. Yeah, -FN name. I'll give the names as something like a limits. That is a container name I'm giving, and I'll just say -D and I'll just say Nginx. So now if I try to run, I'll just I'll just say Docker stats. So here you see, guys, you could see the for your limits like the container which you recently created, you could see that you are giving 256 as a RAM memory. It means that when you are constructing the command, you could see that memory 256 MB. And you could see that actually you are giving a 256 MB. Out of 256 MB, only something like 3 MB is only used actually by your container, running container. And you have given half of the CPU, but here in this case, it is not even consuming half of the CPU also. It is saying 0.00%. So this is the best way, guys, to control your resources actually. So whenever you're running a container, you can able to control it by providing a resource like CPU and the memory in this way in the command line, right? So let me do this. Let me try to kill these two containers because I don't want it. I'll just say Docker container rm-f. I will just give something like a limits, the name of the container and no limits as one more container name. So I'm just try to delete both these containers. So now my question is that Rajesh, when you try to set up a limits by providing this command line like this is for your Docker container. What about your Kubernetes? I want to do the same thing, right? I want to do the same thing for your Kubernetes. So that's what we are going to learn as part of an example for your example 6 is that actually that how you are going to control the resources in Kubernetes. Or you can call it as a limits actually, resource limits, right? So for that, what I'll do, guys, I'll just go to the Google and I'll just try to search for something like resources in Kubernetes. When you try to search for it, you can go to the official documentation like resource management for pod and container, right? You have to go to this link actually, right? This is the link. Please refer to this link. Okay. Now, guys, what happened, right? If you go to this link, it says that resource management for the pod and the container. Now you see something known as the request and limits. These are the two important parameters which you can set it out when you're trying to create a container. For example, here, if you go over here, guys, in this container, what happened, right? You're trying to create a container. This is a pod you're creating, but inside the pod, you are under the spec. This is something like a container. Under the container section, you're providing what is the image you want to provide it. It means that as part of a running container, what is an application image you want to run inside it. Here it is Alpine, right? But whereas you can give any other image, like you can give Nginx or you can give any of your app, you'll provide it. But are we providing any kind of a resources over here or resource limits over here? Nothing. It means that when you are trying to create a pod, by default, what happened, right? What are the Kubernetes by default? What are the resources has to be allocated for this container, right? It will allocate it automatically. You need not to really worry. So is this a best practice to follow? It is not really the best practice, guys. Always you need to make sure that you always provide the limits. It means that when you're trying to create a pod, inside a pod, what are the containers you are running, right? You need to set certain kind of limits, like how much RAM and how much CPU has to be allocated for this container to run. So to set the parameter or to provide these limits, actually, there are two things are the one we call the request and the other is called the limits actually, right? These are two important things, right? So what are these things actually? So we say that actually that this is for the resource and this is for the resource and limits actually. So what we say that request is something like it is a minimal memory or it's like a minimum you provide the CPU and the RAM for your content. Maybe that suppose for example I want to provide some minimal memory. For example, I want to provide for any pod when it is getting right. I need to provide say that memory. I need to just give something like 120 MB. 120 mi, right? And also CPU, I want to provide something like a zero point 0.5 CPU. Now, guys, what is zero point 0.5 CPU? 0.5 CPU is half of the CPU. Now, suppose we know that always we understand the CPU with the help of something like a one virtual CPU. All right, one virtual CPU, or suppose in your system or in your hardware it has two virtual CPU, just a two virtual CPU, right? This is something we call it as a CPU, core CPU, right? One virtual CPU is equivalent to saying something like a 1000 M CPU. 1000 M, or if I say one, both are one the same. Same thing for the two virtual CPU, you can even say two virtual CPU or you can even say 2000 M. So 2000 M is equivalent to two virtual CPU. Similarly, 1000 M is not but one virtual CPU. Suppose, for example, you want to say that Rajesh, I want this is the complete one virtual CPU. So if you say one virtual CPU, it means that the whole one core CPU will be allocated for your pod actually. Right, the whole one virtual CPU. It might use the complete one virtual CPU, or it might use part of the CPU that is immaterial. It means that we are not aware of it, but we will provide one virtual CPU for your running pod actually. Suppose you say that, okay, whatever the one virtual CPU is giving, I don't want to give that much for my pod. I want to give something like half of that. So in that case, what I will do that, I will give something like 500M. 500M is not but half of your 1000. That is not but you're providing something like half CPU. You're providing it. So some people can do like this, like say, so for example, you can say in terms of 500M or 1000M, or in some time you might see even something like zero point 0.5 CPU like this, you provide it. 0.5 CPU is also same as a 500M. So you can either say 500M or zero point 0.5 CPU. Okay. For example, you say that actually that, Rajesh, I don't want to give 500M, I want to give 100M actually. 100M is what? 1/10 of your whole CPU is not 100M, right? Yeah, you can provide even something like 100M also. You can say 100M, 200M, 300M, 400M, 500M. 500M is half of the CPU, right? 250M is 250M is not but one fourth of the CPU. One fourth of the CPU. 100M is what? 1/10 of the CPU. So it is nothing but it is 1/10 of the CPU, right? You can so like this. What happened? This is what the usually the the notations what we provided when you are allocating a CPU for it. Same thing, for example, for the memory, right? So what I'm trying to say that this request, what I'm saying, right? It is a minimum memory and minimum CPU you provide for the pod. This means that this is the guarantee that this much will be allocated for the running pod. It is always guaranteed. Here in this case, what I'm saying that I'm giving the RAM memory as 120 MB and minimum CPU I'm giving is a zero point 0.5 CPU or half of the CPU or just say 500M. Similarly, when it comes to the limits, so this is something what we call it, also we call it as a soft limit. Soft limit is not but the minimum. We call this, we request, we call that as a min, we can call minimum. We can call this as a minimum, and this limits we can call it as a max. Like this. Now here in this case, this is the minimum memory and minimum CPU you're providing to the pod, whichever pod you're creating, right? You are giving something, we call that as a soft link, or we can call it a minimum actually. Similarly, you have something like a limits actually. So limits is nothing but the upper band, upper actually. It means that it's the highest resource what you allocate. This can even you call, even limits, you can even call it as a hard limits. Okay, for the request we call it as a soft limit. This limits we call it a hard limit. You can even call minimum, or you can call it as a soft, right? This limits you can call it as a max, or you can even call it as a hard also. Both are same actually, right? Hard limit is something like an upper bracket, the highest resource which you are allocating. So when you are setting the limits, right, for a pod, minimum you are providing through with the help of a request, you are providing minimum like 120 MB and CPU has 0.5. Here, what you're doing that, Rajesh, for the maximum limit, I will say that the max memory which I'm providing for my pod is 512 MB, okay, MI, and the CPU what is I'm providing is 1, like this. So here I'm providing half of it, here you're providing it plus 1. So where do you get all these details? You will get all these details here in this complete documentation actually. You could see here that, for example, if you're setting a memory request for a container, you could see that you can give 500 MIB, right? MIB means megabyte actually. So you can either say MIB, you can say, okay, or even you can even say just like an M also is fine. Okay, these are two convention which you can see it here. Now, if you come down here, okay, there are resource types are there. What are the resource type? One is a CPU is a resource type, and other is a memory. What are the other things are there? We have something known as a huge pages. So these are the resource limits which are available. So what are the resource types, guys? Resource types. The resource types which are available, which you can allocate for the pod or a container is one is the CPU which you can allocate, yeah, and other is a memory. And apart from that, there is something like a huge pages. Huge pages are not, but it is a more memory you need to provide. You need to provide to the container or to the pod, right? Which is nothing but huge pages. Huge page is something like in terms of GBs of size of memory you're going to provide to the container, right? Then you use something like huge pages actually. This guys, we don't as of now we don't use it actually. Where we use it basically when you're trying to run some very large kind of an application inside your pod, right? Like for example, you're running a Oracle database itself inside a pod. Then in that case, what happened? Your Oracle database might need more memory, more and more memory is required. In that case, what happened? You will set something like huge pages actually. These are the resources which you are going to settle. Right now, we are only playing with the resource type like CPU and memory. Huge pages are not used that much, rarely used, but for only for specific kind of an application, we use this huge pages actually, not for everything. Okay. So here, what happened, guys? You are having something known as a resource request limits for the pod and the container. See, these are the limits which are setting for your CPU and the memory and the huge pages. Lower limits are nothing but we call it as a request. Higher limit is something we call the limits actually, right? And if you come down, this is the pod level. This is for the container level specific resource, what you said, and this is for the pod level specific. Even for the pod or container, both are same only. Here also you could see that for the pods, you are setting the limits for CPU, memory, and huge pages. Same thing for the pod level resource specific also. Same thing you are setting CPU, memory, and huge pages. Nothing. Both are same here in this context actually, right? And what are the resource units? Resources unit in your Kubernetes? For the CPU, we always say one physical CPU or one virtual CPU. That's what I was saying it actually, right? And you could see that you can even set it as a zero point 0.5 CPU. Zero point 0.5 CPU is not, but half of one is zero point 0.5 CPU. It means that you can either call it as a 500M or you can even call it as a zero point 0.5 CPU. All right. And you could see that, like, for example, you can say that for the CPU resource, the quantity expression is 0.01 is equivalent to 100M. See, 100M, you can even call it as a 0.01 also. It is not but a 1/10 of your CPU actually. Same thing, if you come to the resource units in Kubernetes like CPU, you have something like a resource for your units for your memory also. So the memory is something like where you say it as a PI, KI means kilobyte, MI is nothing but memory, megabyte. GM is gigabyte, terabyte, petabyte, exabyte, like this. These are the higher values. So most of the time, 90% of the time, we will always be seeing that our resource limits for your memory, either it will be in kilobytes or megabyte. Rarely we see that we go with the gigabyte. We don't go that much, but we will see that most of the time, 90% of your time, all your pod resources, what the memory are allocating will be in terms of megabyte only, right? So you can either say, suppose for example, I want to just say 128. You can either say 128 M, you can say, or you can just say 128 MI, or you can even say 128 MIB. Anything can be called. That's what I said that 188 MI, 188 M, or 128 MIB, or I'll just say MI. That's all. All this nomenclature are same. You can use any thing. But most of the time you will see that you will be using something like 128 MIB. Like this, you will be using it when it comes to Kubernetes, right? You will be using this kind of a notification. right? Similarly, like for example, so that is how they are given an example actually. So if you come down here, you could see guys actually that under the container, under the here you have something like resources, and here are you having a request. Requests are nothing but your minimum memory and CPU what will be allocated for your container, right? This is a minimum which will be allocated actually. Maximum how much it can go up to the whatever you have set under the limits. So you could see that for your running content for this container, minimum CPU is about 250 M and memory 64 MI will be provided. What's the maximum remote limits where you can set up for this content is under the limit section where you're giving memory as 120 M, which is more than 64 M, and where you are setting a CPU of 500 M or half of CPU. So this is what you are going to set the resource limits now. Am I clear, sir? Guys? Okay, good. Now the question comes, okay, Rajesh, all these days we are not passing anything over here. When you're trying to create it, we're not passing any. You try to see in the pod one example or pod through pod three. Anywhere you see that we are not passing any kind of a parameter like resources, right? We are setting it now. How come suddenly we are trying to understand this? Guys, it is very important that whenever you're trying to create a pod, right, you need to provide or you need to create a pod under some resource restriction you have to provide it. You cannot just simply leave it to Kubernetes to decide like how much memory or CPU has to be given for that for the newly created pod. You should not leave to the Kubernetes. Instead, what happened? A user has to do it because we know that whenever any kind of an application is designed, right, the developer has designed an application, he has written a code for that, and also we will get some information about like what is the minimum and the maximum resource that application might require it to run actually, right? So the developer might give information saying that okay, it needs minimum one virtual CPU to run it. Maximum it might need up to five virtual CPU to run because during threshold, right, what happened during more and more when more and more load comes onto the application, right, it might need more number of CPU and more number of memory. At that time, what happened, right, it might request for more and more RAM, and it might request more and more resources for it to run in a proper way. That's what happened, right? It can go maximum up to some threshold level where it might need more memory and more CPU. So in that case, what happened, right? You can set some kind of a resource constraints for this running pod. If you leave it as it, what happened, right? Maybe what happened, whatever the node under which the content that pod is running, right? It might use maximum memory and maximum CPU what is provided by that node. That shouldn't happen right in the real time, right? Because there are many other pods are there which are running the same node. So it might get affected actually if one container, if it is using or if it is monopolizing the whole resources which is provided by that particular node, right? For example, here in this case, if suppose we are having two nodes here, like sorry, one node we are having, node one, and we know that there are some resource limits are the constraints are the node one because we have only one virtual CPU and 2 GB of RAM memory. You cannot say that okay, well, I will give all the resource for only one pod, right? Then what about other pods which are running? It might fail or it might go to the threshold where it might not really not able to properly work, so the latency will fall it and the application will not be responding very fastly, right? Other pods application will not respond very fastly. So we have to always maintain the resource constraint for each and every pod which is created in the Kubernetes cluster. So it is always a best practice that you use this resource limits whenever you are trying to build the manifest file. Without the resource limits, guys, it is not a good practice. You have to use a resource limit. This is one of the by a preliminary, requirement for you to write a manifest file. Whenever you're writing any manifest file where you are specifying about the pods information, you need to always specify the resources actually. Without the resources, if you're trying to write a manifest file, it is a bad practice. Anyone who's your lead and all that, he might ask a question why you're not setting a resource limits for your newly created container or newly created pod, sorry, in the manifest file, why you're not mentioning about this, he might ask you the question. So always mentioning the resource limits are the best practices when you write a manifest file, right? Because we are see what happened, right, when you're trying to set a resource limits for your pod, which is pod which get created, right? So ultimately it might at the initial stage it might run actually over a period of time, say for example after 1 hour or 2 hour, you might see that your pods are continuously getting restarted. It means that actually that there might be some kind of resource constraints might be there, okay, because of which it might be restarting always, or else sometime what happened, right, the latency of your application which is running inside a pod, right, it will be very slow. you will see the response time is, it takes more time to respond it. So then in that case, what happened, right? If you try to go and check it out, what are the resources constraints, or what are the resources which are being currently consumed by your pod, you will see that actually it has used the maximum CPU, like 100% of the maximum CPU it has allocated. And also what happened, you will see that the memory, whatever you are provided, right, it is requiring more and more CPU, RAM memory. So guys, whenever if your pod it needs more and more RAM memory, ultimately what happened that your pod will get fail. Even though you set the resource limits like this, if your pod, writing here, if the resource limits are set, if the resource limits are already set, and if the running container, or sorry, if the running pod needs more and more RAM memory or more and more memory, okay, then the pod might get failed, and you will get pod status as OMM killed, like this. Out of memory, it get killed, right? For example, if the pod needs more and more CPU than the resource limits, in that case, pod will not be failed, but pod will go to the threshold where the response, or can say that latency, will be too high. It means that your application response will be too slow actually. The response time it will take more actually. So in this case, what happened, guys, when there is a issue with the memory, at that time what happened that your pod will get killed actually. If there is any yeah, that's what means that if needs more and more memory, obviously what happened, there's no memory available, because you have set the resource limits here. So limits, highest limit what you have given is 120 MB. For example, your pod might need something like 150 MB it might need. No, it might not serve, because here you have set the limits, right? 120 minimum is 64 MB, and maximum what you have given is 120 MB. In that case, what happen? Your pod will get failed. That's what you will get, a pod status error as OM killed actually. Right? Whereas when it comes to CPU, here you are given 250M and the maximum is 500M. Maybe your container might need something 750M. So in that case, what happened, right? It is reaching the bottleneck, but that will the CPU resource constraint will not make your pod to get killed. But your pod will be running, but it will see that the response time will be too slow. It will be that your application, what is running as part of that container, right? Or as part of that pod, right? The response time it takes is too slow actually. So your responsive is, it takes more time to respond for a request actually, because it has reached that bottleneck actually. It has reached that threshold level, right? So this you have to keep it always in these 2 points, you have to keep it always in your mind. Am I clear, sir? So shall we write a container here? Sorry, actually we write a manifest file for you to show it. Anyhow, you have seen this example, right? You can make out easily, but still, okay, let me know that. Let me try to write a write an example, or write a manifest file. So what I'll do, I'll just say pod-6.yaml. Okay. Now let's write. So we know that always it starts with the 3 hyphen. Okay. So we know that we are a API version v1 kind, what is it? Pod and metadata, and we have something like a spec. Correct, guys? Right? Now, okay, metadata, what I will give that? I'll just give only one field, like name. What is it actually? I'll just say, I'll give some name. One I'll give, that's all. In the spec, actually, we know that you have to give two space. You know that there is something like a containers. Okay, by this time you're already aware of it, right? And you give two spaces, it's an array, right? I have to just say hyphen name. I'll give something like web actually. Some name I'll give web. And then I'll give the image name as Nginx, right? After that, so if you go back here, to your API reference documentation, so here you could see that, guys, you are under your container actually, right? You are under your containers here. Under that, you are providing the name as well as you are providing the image details. What about anything is there, guys? Anything known as a resource? Can you see resource limits? Resources are there. It is of a type resource requirement actually, right? So let me write something like a resources. RESOURURCS actually. RESOURCES. Yeah, resources. I'll give two spaces here because it is of an objective resource requirement, right? If you click on it here, it will take you something like a limits and the request, and it is of a object type. And if you want to get this information, you can go through this URL what they provided. You will get more information. But we are aware like there are something like a limits is there and there is something like a request is there, right? Let me know the let me give just a requests. So requests, yes, and there is something like a limits. Yeah. Am I clear, sir? Right? So now what I will do that I under the requests I will give two details. One is the CPU and other is the RAM. So give two spaces. I'll just say CPU and I'll just say memory. So request is not but it is a minimum or but a soft limit, right? What you provide it. So what is the soft limit you're going to provide? You will say that okay, Rajesh, uh, for my request, let me do one thing. Let me give the CPU or something like a 100 M or I'll just say zero point 0.1. I can either say zero point 0.1, I'll just say 100 M. Minimum of 100 M of CPU is provided. And memory, what you're going to provide, you're going to provide something like a 128 MB or I'll just say 128 M. Am I clear, sir? Right? This is what it is, right? And for the limits, what you provide, these are max actually. You'll give two spaces, I'll just say CPU. I'll just give something like a 500 M, half of the CPU. And memory is something like, what is it? 512 M actually. Right? Is there anything else is required, guys, for this? Nothing, right? Yeah, this much is sufficient. So I'll just copy it, come over here and go to the master node. I think I've already logged out. Like, let me log in again. Okay, I don't think that I'm running anything over here. The worker node, so Docker container ls, nothing is there, guys. I'll exit out. I don't need this node at all. Right. Okay, I've logged in. I'll go to the manifest file. I'll just say pod hyphen, what is it? 6.yaml. So this is what, so here you could see that you have learned something, a new section, which is called the resources. Under that, you have requests and limits. Request is a minimum and limits is a maximum, right? Or this is something like a soft limit, and this is what is a hard limit actually. Right? So what do you mean by that? This much is guaranteed that will be allocated for your pod. But apart from this, if your pod needs more and more memory, it can go up to 500 M CPU, half of the CPU. It can go up to 512 MB of memory. This is a hard limit you are setting for your running container. Beyond this, what happened? Your pod will either will get failed, or either what happened that it will go to a like it will go to something like a stage where it will it go to the highest maximum threshold level of CPU. It might go if it needs more than this actually, right? But for the memory, we know that the pod will get terminated if it needs more than 512 MB, right? So I'll save this file and I'll just say kubectl get pods. Let me see if there are any pods are running. No pods are running. I'll just say kubectl apply -f and I'll just say pod -6.yaml. So you could see that pod is getting created, guys. So if you execute the kubectl get pods, you could see that your pod is in a state of container create. In some time, this will come up actually, right? You could see that it has come up in a running state, right? So if you try to do kubectl get pods -o wide, you see that your pod, this pod, one pod, it has created in the node 1 actually, right? Now, if you want to get information about this pod, what we do basically, we run a command kubectl describe pod and specify the pod name, that is 1. So if you try to do it here, if you try to run it, now you could see it, guys, actually that we know that actually this will describe your running pod actually. But out of here, all these things we know that here you could see under the container section, you have something called limits. See, whatever the limits you have set, right, that you will be able to see over here actually, right? And also you will see some other important thing which we call it as a QoS class is burstable. So what is this QoS class? We will see it in some time now. So these are the two important things which you have to observe it when you try to execute kubectl describe pod and specify the pod name, right? Okay. Now, fine. So, what is an impact of understanding about this resource? Yeah, obviously, when we try to learn about the pods, yes, we need to know why we have to set the resource constraint. Yes, resource limits or constraints we have to set for whenever you try to write a manifest file. That is the best practice what you have to follow, right? And the important thing that this pod with these resources, right, whatever is setting, right, it has an impact on something we known as a QoS actually, right? What is this? What do you mean by QoS? So a pod with resources, resource limits, I'm saying resource limits has an impact on QoS. QoS means quality of service. So this is an obvious question which will be asked in interview always. Can you tell me what is QoS is all about? And also they might ask you like what are the different types of like QoS are there? Can you tell me? So this is a very, very obvious question which they ask in many of the interviews, right? So if you go to the Google and if you just try to do a Kubernetes, what is it? QoS. So if you come over here, can you see a configure quality of service for pod? Yes. If you go over here, guys, you could see that actually that how to configure pods so that they'll assign a particular QoS classes actually. So these are the three types of classes of QoS. One is about guaranteed, burstable, and best effort. These are the three types of or classes of your QoS, right? So quality configure quality of service means like what is the best way you will provide the resource for your running pod. That is what we call as a quality of service, right? And these are the three types are there actually. Guaranteed, burstable, and this. So I would recommend you to go through this document also. Refer to this document. So as I said, guys, earlier also, the ultimate truth of or the source of truth of learning Kubernetes is through only through documentation. There is no other way where you can learn like without the document. Documentation is the one which will give you almost all the information what you need actually. So right, you have to learn through documentation. There is no other way to learn it actually. Am I clear, sir? So now, right now you could see that actually in the Kubernetes, when you create a pod, it aligns to three QoS class of the pods. Either it could be a guaranteed, burstable, and best efforts actually. These are three. So what do you mean by guarantee? Guarantee is something like where there is no upper limit or there is no limits actually. There is no upper limit like this. There is no limits. Only you have only knows a request only. It means that whatever the minimum you have provided, right, that much will be provided for your pod. No more than that. It means that request and limits are same when it comes to guaranteed actually. So how do you know that? If you just click on this guaranteed, it'll take you to that pods that are guaranteed have a restricted resource limits and are less likely to face an eviction actually. So what I mean by eviction, we will discuss in some time. Okay. So they're guaranteed not to be killed until they exceed the limit or there are no lower priority pods that can prevent from the node. So what it says that actually that they say that actually that like the maximum and the minimum whatever you are setting it for, right, they all must be equal. It means that whatever the limits you're setting, right, the maximum is nothing but the limits and the minimum is request, right, for burst up for the guaranteed both are equal actually. Both are equal. Like for example, somewhere they're given, right, every container pod must have a memory limit and the memory request. Every container pod must have a memory request. Okay, the pod must have a pod level memory and the memory request, and their values should be equal. The pod must have a CPU, pod CPU limits and pod request, and their value should be equal. This is what they are giving it actually. I think they have given some example also. Uh, burstable. They should have given some pod level resource instead of pod level resource. Guarantee that. Somewhere there, I think they have removed that section, I think now. These are the ephemeral, okay. Where is bustable, man? Okay, man, I think they removed that section actually. But they used to have that we call the static CPU, right? What are the memory? Static means you're providing only one value, right? You're not changing it actually. Okay, burstable is something like where you have a lower limit and you have upper limit. Like for example, here in our case, whatever we are providing, right? For this example, right, where I'm setting a request or nothing, but the minimum value or soft limits and the maximum value. This is what we call it as a burstable. Burstable means basically you will set a limit for lower limit and the high limit. That we call a burstable. So pods that are burstable have some lower bound resources guaranteed based on the request, but do not require a specific limits. If the limit is not specified, it defaults to a limit equal to the capacity of the node, which allows the pod to flexibility increase it actually. So that's what we call the burstable actually. That's what you remember, right? When I try to do it, can you see here? QoS class is burstable. So what are this pod is running, right? This the QoS class, it falls under the burstable type because here I have set the limits, the lower limit and the upper limit, both the things I've set over here. That's what we call it's a burstable actually. So what is the best effort means? Best effort is something you are not at all mentioned anything like that. For example, in all our previous case, like in pod 5, you have never mentioned any resources also, any resources, right? You're not set any kind of limits over. It means that you will decide to Kubernetes to decide what is the CPU and RAM memory need to be provided. That is what we call it is a best effort. So does best effort is good for our best practice? No, sir. Best effort is not good. But they gave the name as a best effort as a QoS, but it is not good. We have to always go with the bustable only. It means that you need to set up a lower limit and the upper limit. Both you have to set as part of your manifest file. You have to set it up. Am I clear, sir? Okay. Okay, good. So here in the bustable also, they have given here they used to have an example, but I think they removed it, guys. They don't have that example actually. Or else here somewhere it's there. Memory with QoS, best effort, guaranteed. They same only. QoS class, some behavior independent of QoS classes. Resource management for pods. This is resource management. Node pressure eviction. Eviction signals. Okay. This we'll discuss later, guys. All these things. Uh, Eviction hard eviction. This I'll be discussing later, not now. No, guys. That example they have removed. QoS. Learn about QoS. Okay. Here. Uh, yeah. This is what we call it is for the guaranteed. Can you see here, guys? Limits, RAM and CPU. For the limits is higher limit. The request is lower limit. Can you see the values are same? For the memory, it is 200 M, CPU 700 M. Here also 200 M, CPU. This is what I was saying. This is for your guaranteed. If you come down here, they would have given for something like a burstable. Burstable, we know that we'll set a limits of something higher memory and lower memory or CPU also. For your best effort, we don't provide anything over it. See, for the best effort, you don't provide. Like how all these days we are doing, right? Without setting the resources, we were running the pod, right? So this is the best effort, but this is not the ultimate thing which you have to use it. So, okay, you can refer to this link also for examples. Am I clear, sir? Guys?
Yes, Rajesh. Yeah.
Okay, guys. Okay, fine. So, guys, I'll think that I thought I will cover many things, but anyhow, we'll stop it now here. What we'll do tomorrow, we will start with the labels. Next class, I'll stop it here today's session. Next class, we are going to continue with the labels. We'll start with the labels. And also, I will try to take tomorrow. I have to go to office. I think morning I can take the class at 8 o'clock or 7:30 is fine for all of you. Morning, I'm not sure how many people will join, but Karthik and
Yes, yes,
Naveen, uh,
yes, yes,
yeah, you guys can you at least you guys will be there, right?
yes, 7,
Yeah, Rajesh. Yeah.
7:30 is fine for you. Morning 7:30.
7 a.m.
Huh? 7?
7 a.m.
7
7 or 7:30, whatever. Naveen and the other
Yeah.
people, I'm not sure. Dipali, I'm not sure whether you'll be able to join or not. I'm not sure. But at least I know Karthik and Naveen and these two people are regularly joining. So at least if these two guys are joining, at least I will take. So what do you say, guys? 7 a.m. is fine for you? Next class? Tomorrow morning, 7 a.m. I say.
Yes, sir.
Yeah, Rajesh, fine.
Oh, great, great. 7 to 8:30, I will take the class. So what I will do means I will have a next session is labels I will take, and then like we'll try to understand about the introduction to the pods and pod states, different states actually. Okay, and we will also learn about something like Kubernetes. What is it? Labels is there. What is it? I will try to even discuss about the namespaces tomorrow only. Right? These are the three important topics which I'll be covering tomorrow morning. Okay. If you're not able to cover, again, it'll go to the next class actually, right? So guys, what I will do this week, since I didn't take much class in this week actually. So what we'll do that we will plan to have Saturday morning, this weekend we'll plan to have morning, we'll have a Kubernetes session morning. Evening, what we'll do that we will try to start with the AWS class. So in evening, we'll have one session. We'll start with the IAM service actually, right? In the Saturday evening. And again, even the Sunday evening also, we will try to take AWS only. And Sunday morning, we will have a Kubernetes session. So this week, we have two sessions, morning and evening. Morning, we'll try to cover Kubernetes, and evening, we'll try to have a AWS class. Is it fine? So slowly we will also accelerate even in AWS also, so that we will try to complete every like we'll try to service we'll try to complete one service, right? Like this we can at least we'll try to spend some 2 or 3 classes like this. Okay. So that's a plan action for this week, guys. So tomorrow morning 7 a.m. we'll have a class.
Okay.
Thank you then. So let me stop the recording.